Okay, let's talk about applications of the normal distribution. All right. Now, if we convert values to standard z-scores using formula 6.2 here, this is formula 6.2, then procedures for working with all normal distributions are the same as those for working with the standard normal distribution. So what we're going to do is we're going to take a given x value that comes from a non-standard distribution, and we're going to convert it to a z-score, round it to two decimal places. We're going to round these z-scores to two decimal places. And once we've converted it to a z-score, we're going to use that z-score to find the probability. So it turns out that even given a non-standard normal distribution, using this formula, we can convert it to a standard normal distribution and find z-scores using table A2 or our calculator. So this is the formula that takes a non-standard normal with mean mu and standard deviation sigma. Given a value of x, we convert it to a value of z using this formula. And then we'll be able to draw a standard normal distribution with a mean of 0 and a standard deviation of 1. All right, so let's take a look at this example. IQ scores. In exercise 5 through 8, this is number 6, find the area of the shaded region. The graph depicts IQ scores of adults, and those scores are normally distributed. Very important. We're being told that it's normally distributed. So any x value that we're given, like this x value here, we can convert to a z-score with a mean of 100. So here's mu, mean of 100, and a standard deviation of 15. So here's sigma. So we've been given the mean and the standard deviation mu and sigma, and we've also been given a value of x. So what we want to do is we want to find the area to the right of this score of 80. Okay, so in order to do that, what we need to do is we need to use the formula that says z is equal to x minus mu over sigma to convert this to a standard normal distribution. And once we've done that, we are going to find the area to the right of that z-score that we find, and that will correspond to the area to the right of 80 in the non-standard normal distribution. So we're going to take 80, which is x. We're going to subtract from it the mean, which is 100. And we're going to divide that by the standard deviation, which is 15. And when we get the answer, we're going to round that answer to two decimal places. So that's 80 minus 100 divided by 15, which gives us negative 1.33 when rounded. So this is about negative 1.33. So this is the z-score that I need. All right, so what I've done is I've started with a non-standard distribution. This is my non-standard distribution right here. I've started with a non-standard distribution, and I've used this formula, this z formula, and I've converted it from a non-standard distribution now to a standard normal distribution. And this is what my standard normal distribution will look like. Well, that's supposed to be a symmetric bell curve, but my art isn't the greatest. And the mean here will be 0, and we just found the z-score. We just found the z-score right here to be negative 1.33. And this z of negative 1.3 corresponds to a score of 80 in the non-standard distribution. And we're looking for this area up here. We're looking for the area under the curve on the right-hand side. Now, what we're going to do is we're going to put this information into the calculator. But if you remember correctly, when we're putting these kind of problems into a calculator, what we want to do is we want to use the normal CDF, normal CDF, and we want to put in the left z-score, left z, and then we want to put a comma, and then we want to put in the right z-score, right z. So we need a left z-score and a right z-score. Well, I have a left z-score, which is a left boundary for my area, but there's no upper boundary. So what we're going to put in for the upper boundary is we're going to put in infinity, basically. And the way to tell the TI-83 calculator infinity is to put exponential, which is e. This corresponds to the notation times 10 to the power that's going to come after it. So the number that's going to come after it is 99. So this is going to be like 1 times 10 to the 99th power. All right. So let's go ahead and do that on our calculator here. We'll bring out our TI. So we have our TI here. And like we said, we're going to use a left endpoint of negative 1.33 and a right endpoint E99. So we'll turn it on and let's clear this. We're going to go to the distribution. So we do second, so we can get the arrow on the cursor. We hit vars because we want the distributions, and we are looking for number 2, the normal CDF. So we hit number 2, and we're going to put in our left endpoint, which is negative 1.33. That's the left z-score here. Then we're going to put in the right z-score, so we put a comma. The comma is here, and we put in the right z-score of E99. That's how we tell the calculator infinity. Well, E99, if you notice right above the comma, they actually have the E there. That's what I want to do. I want to hit second, and then I want to hit the comma, and it puts an E on the screen, and then I'm going to put 99. So this is like 1 times 10 to the 99th power, a very, very, very large number. And we close the parenthesis, and we hit enter, and we find out that that area, in both cases, for the non-standard and for the standard, they correspond to each other, is 0.9082. So this area here is 0.9082. It corresponds to this area over here, which is also 0.9082. So we've used the standard normal distribution, the z, in order to find the area to the right of this non-standard normal distribution. All right, so let's take a look at another example here. Here's another example, and we're asked to find the area here. Now what we're going to do is we're going to convert this to a z-score. We're going to convert both of these x values, because we have now 2 x values, x here and x here, which are going to correspond to my left z-score and my right z-score once I use this formula. So z is equal to, first I'm going to do it for my left z-score, the 75, the smaller number. 75 minus 100, and we're going to divide that by 15, x minus mu over sigma. So that's 75 minus 100 divided by 15, which gives us negative 1.67 as a z-score. We're rounding it to 2 decimal places, negative 1.67. And then we're going to find this is the left z-score. This is the left one. Now we're going to find the right z. The right z-score is going to equal, let's see here, we have the right z-score being 110 minus 100 divided by 15. And let's see what this z-score is. That's 110 minus 100, which is 10, and we're dividing that by 15, so we get 0.67, 0.67. So now we've used the z formula to convert this standard normal distribution, or this non-standard normal distribution, to a standard normal distribution. Here's a picture. We have on the left side negative 1.67, and on the right side we have 0.67, and the area between these two corresponds to the area between 75 and 100 in the non-standard. So all we have to do is find this area, and in order to do that, we're going to do, once again, normal CDF. We're going to put in the left z, which is negative 1.67. We're going to put a comma, and then we're going to put in the right z, which is 0.67. And this is the function that we're going to put into our TI. And it's going to give us the area corresponding to the area between 75 and 100. So let's go ahead and do that. Let's bring out the TI 83 here. And let's see, we're going to once again turn it on, clear. And we're going to second again. We're going to vars because we want the distributions. And we're going to normal CDF, which is number 2. And we're going to put in the left z, which is negative 1.67. We're going to put the comma, then we're going to put the right z, which is 0.67, and we're going to close the parenthesis, we're going to press enter, and it turns out that this area is equal to 0.7011. So let's see, this is equal to 0.7011, which means this area here is equal to 0.7011, which corresponds to this area here also being 0.7011. So we found the answer, we found the area between those two z-scores. All right, now there are the cases also where we're given the area and we want to find the actual score itself. Now in those cases we want to use this form of formula 6.2, where this z-score is the z-score for the given area. So this is the z-score of given area. So once they give you an area, the first thing you need to do is find the z-score for that area and plug it into this formula to find the value of x that you're being asked to find. So let's go ahead and look at an example of that. IQ scores. So in this example, we need to find the indicated IQ score. So now we're looking for a score and we're going to be given an area. The graph depicts IQ scores for adults, and those scores are normally distributed, again, normally distributed, with a mean of 100 and a standard deviation of 15. So once again, we're being given mean, mu, and standard deviation 15 sigma. Well, let's see, we have 0.8 here. And what we need to do is we need to find the z-score that separates the top 80% from the bottom 20%. This is the 20th percentile, actually. We're finding the z-score that represents the 20th percentile. And that'll actually give us the 20th percentile of IQ scores, the score that separates the bottom 20% of IQ scores from the top 80%. But if you remember, that function in our calculator, inverse norm, that function, we had to plug in the area to the left. We had to plug in the area to the left of the score, the z-score we wanted, and then it would give us the z-score. What we're being given here is the area to the right. So what we're going to have to do is, since this is the area to the right and we want the area to the left over here, we're going to have to do 1 minus 0.8 to find the area to the left, and 1 minus 0.8 is 0.2. So what we're going to do is we're going to do inverse norm of 0.2. And that'll give us the correct z-score that we need. And this is going to be the z-score for the given area, and then we're going to plug it into this formula up here to find the x value, or the IQ score. So first we find the z-score, then we find the IQ score. So let's bring out the TI. We're going to need inverse norm, so we turn it on first. Then we hit second. Oops, well, let's clear it first. Let's clear it. Then we're going to hit second, and then we're going to go to distributions, and we want inverse norm, which is number 3. And we're going to put 0.2, which represents the area to the left. Remember, we have to put in the area to the left, and then we press enter. And it tells us that the z-score that we need, the z-score, it says is, what was that z-score? That was negative 8.4. Remember, we round z-scores to 2 decimal places, so negative 0.84. Negative 0.84. That's the z-score in question. And now we're going to use the z-score of this given area to find the x value, or the IQ score, using this formula. So that's going to be, let's see, x, which is the IQ score we're looking for, is going to be equal to, first we take mu, and mu is 100. And then we're going to add to it this given z-score, which is negative 0.84, times the standard deviation. And the standard deviation in this case is 15. And this gives us the x value of, let's see, 100 plus, and then we have negative 0.84 times 15, and we get 87.4. 87.4. So 87.4 is the x value that we're being asked to find here. This x value is equal to 87.4. All right, let's look at another example here. And in this case, we're being asked to find the x value, and we're being given the area to the right. So in this case, there's no need for us to subtract from 1 because we're already being given the area to the left. This, in fact, is the area to the left. So all we have to do is go to our TI-83 here. Go into the TI. And what we're going to do is we're going to type in, actually, let's write it out first. We're going to type in the inverse norm, and then what we have already is the area to the left, so we're going to do the inverse norm of 0.99. This is going to give us the z-score that we need, and then we're going to plug that z in and find the correct x value. So let's go ahead and do that. All right, so the z-score that we're looking for, well, we're going to turn her back on. Let's see, clearer. Then we're going to do second vars to get to the distributions. And inverse norm is number 3 again, and we're going to put in 0.99, close the parenthesis, enter, and it gives us the z-score should be 2.33. So this is going to be 2.33. So now I have the z-score that I need, and in order to find the value of x, I'm going to just have to do mu plus, and then it's going to be the given z-score that I just found times sigma. Well, let's see. Mu is 100 plus z, which we just found to be 2.33, times sigma, which is 15. So the x value that they're asking us to find here, the x value is going to be 100 plus 2.33 times 15, close the parenthesis, and we get 1.3495. So this is 1.3495. And I wish we can round to about 1.35. Or sorry, I have that, I'm placing the decimal in the wrong place here. This isn't 1.35, this is actually 134.95. 134.95, which I'm going to round to 135. So we'll call the correct x score here, x value here, the correct IQ score, 135. So an IQ score of 135 places you in the 99th percentile, meaning your IQ is higher than 99% of the population, or 99% of the people who took this test. All right, here's the last example we're going to look at. In this exercise, what we want to do is we want to use this information about men's heights and women's heights. It says that men's heights are normally distributed, so we can use z-scores here with mean of 69, so this is mu given, mu, and a standard deviation of 2.8, and they also gave us sigma. Women's heights are normally distributed, so once again, normally distributed women heights with a mean, so women have a different mean. The mean for women is 63.6, and the standard deviation for women is 2.5. So women are generally shorter, and their heights vary a little less. They're closer in height. All right, so let's look at number 22. It says the Gulfstream 100 is an executive jet that seats 6, and it has a door height of 51.6 inches. So the height of the door of this jet is 51.6 inches. Part A says, what percentage of adult men can fit through the door without bending? Well, in order to fit through the door without bending, your height has to be a smaller number than 51.6. Otherwise, if you're taller, you have to bend down at least a little bit in order to fit through the doorway. So what we're looking for really is the percentage of men. We're looking for area. Whenever they ask you to find percentage, they're asking you to find area. We're looking for the percentage of men who have heights that are less than the height of the doorway. And the height of the doorway is 51.6, which is actually on the left-hand side of the mean for all men. Because the mean for all men, the mean, mu, is 69 inches. So the mean height of men is 69 inches, and this doorway is only 51.6 inches. So the x value that we're being given, x is equal to 51.6, and we're looking for the area to the left of 51.6. So we're looking for this area over here. All right? The mean is 69. We're looking for the area to the left of 51.6. Well, what we're going to do is we're going to use the inverse norm again. Not the inverse norm, sorry. We're going to use the normal CDF. The normal CDF gives us the area if we give it a left z-score and a right z-score. Now, this is the area, this x value is actually to the right of my area. So it's actually going to give me my right z-score. The left z-score is going to be actually negative infinity, because this thing goes on out here to negative infinity. And this, of course, continues and it never actually touches. So we're going to use negative E99, like in the same way we use E99, negative infinity is going to be negative E99. So that's what we're going to do here. Let's see here. So we're going to use the normal CDF, the normal CDF, and we're going to plug in for the left endpoint negative E99, and for the right endpoint, we're going to plug in the z-score corresponding to an x value of 51.6. So let's find that z-score. Let's see. Z is equal to x, which is 51.6, minus mu, which is 69, divided by the standard deviation. And the standard deviation here it says is 2.8. So 2.8 for men. So let's see what that gives us. This z-score is then going to be, we have 51.6 minus 69, and we divide that by 2.8, 2.8, and we get a z-score of negative 6.21, negative 6.21. All right, so negative 6.21 is going to be the right z-score. So we've converted this thing uh, from the non-standard normal to the standard normal, and we found that the z-scores we're going to be looking at are negative 6.21, and that's going to be the right z, and the left z is going to be negative infinity, which we're going to use negative E99. So we've converted it here, so we're going to find that area, which corresponds to this same area over here, this entire thing. So we're going to put in normal CDF, negative E99 to negative 6.61, close the parenthesis, and we'll get the area between negative infinity and negative 6.61. So let's go ahead and bring out our trusty TI again. Let's see. So we're looking for, let's turn it on and clear. And second, distributions. We're going to go to the normal CDF again, the normal CDF. And in the normal CDF, we're going to plug negative, and then we're going to do E again. Remember, E is above the comma. So negative E99, which is negative infinity, comma, negative 6.61. And we press enter. And the calculator gives us a, this actually is scientific notation. This is 1.931 times 10 to the negative 11th power. 1.931 times 10 to the negative 11th power, which is basically a decimal point, 10 zeros, and then 1.931. So that's decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 1, 9, 3, 1. So this is an extremely small probability, or an extremely small percentage of men who would be able to fit through the doorway without having to duck down. All right, so let's go back to the question. Part A is, what percentage of men can fit through the doorway without having to bend? Well, the answer is um, this fraction, or this is the decimal form of the percent for part A. So part B says, well, part B is, what percentage of adult women can fit through the door. So let's skip that one. We will be doing the exact same thing, but with this mu and this sigma, and we would find the probability that a woman would have to duck down in the exact same way. Part C. Does the door design with a height of 51.6 inches appear to be adequate? I would say no, because a majority of men would have to bend down in order to get through this door. So if this is the percentage as a decimal of men who don't have to bend down, well, that means it would be really, really rare for a man not to have to bend to get into this jet. So it doesn't seem like the height of 51.6 inches is adequate. And part D, what doorway height would allow 60% of men to fit through it without bending? So basically, let's look at part D. What we want is, we want to know what doorway height would allow 60% of men to fit through the doorway without bending. So basically, what we want is, we want to know what the 60th percentile is. We want 60% down here, and we want to know what this x value is. We want to know what the x value is that separates the bottom 60% from the top 40%. Basically, what we're looking for is, we're looking for the 60th percentile. That's really what we're looking for. All right, so this is what we're going to do. What we're going to do is, we're going to have to find the z-score that separates the bottom 60 from the top 40%. And then we're going to use the formula x equals mu plus z times sigma in order to find what the actual height is that separates the bottom 60% of men from the top 40%. So let's go ahead and do that. So the first thing we want to do is, we want to find out what the z-score is that separates the bottom 60 from the top 40. So let's take out our calculator, and we're going to find that z-score, and we're going to do it with the inverse norm. So second, and we're going to go to distribution. Oops, let's turn it on first. Clear this. Second, we're going to go to distribution, then we're going to go to inverse norm this time, the inverse norm. And we're going to put in the area to the left of the z-score, which we want. And let's draw that picture. Actually, I haven't drawn that picture. That picture is going to look something like this. What we're going to do is, we're going to be looking for this z-score right here that has 60% on its left. That's what we're actually looking for. So we're looking for this z-score, and once we find that z-score, we're going to convert it to a actual height using that formula. So let's go ahead and do that. Let's see. So the inverse norm, and we're going to put in 0.6, which is the area to the left of the z-score we're finding, and we find that z-score is equal to 0.25. So 0.25. So this z-score is 0.25. And now we're going to find the x value that corresponds to that. The x value that corresponds to that is going to equal mu, which we said the mean height of men, we said, was 69 inches. So that's going to be 69.0. That's mu, 69.0. So that's mu. And then we're going to add to that z, which is 0.25, times sigma. And sigma, we said, was, if you recall, 2.8, right? 2.8. So this is going to give us the x value that we need, 2.8. So we get 69 69 plus 0.25 times 2.8, and that yields for us 69.7. So the x value that we need is 69.7. That's the x value. That's the height that separates the bottom 60% of men's heights from the top 40%. So if you're taller than 69.7 inches as a man, you're taller in general than 60% of all men. Okay.